Okay, here's where we left off on Friday, okay? We talked about, you already have all these notes, we talked about the modern atomic theory, electrons, protons, neutrons. We got some new terms, but we didn't have time, because we watched the second half of the Bill and I video, we didn't have time to actually go over, actually doing calculations with this. That's what we're going to do today. I'm going to do about 10 minutes worth on the board here of how we can do calculations with mass number, with atomic number, all right? And I'll kind of refresh your memory on this. And then I'm going to give you 2 worksheets to work on. And that'll be basically it, because we already spent part of this period going over the test. All right? So, what terms are we going to use today? Well, we're going to use atomic number. We're going to use mass number. So let's remember what they are. Atomic number is very simply the number of protons in an atom. And it's on your periodic table. It's usually at the very, very top. It's usually bigger than the other numbers, like that one is up there and on here. The mass number is not on here. This is very important. The mass number is not on here. Okay? The mass number is actually just the protons plus the neutrons. So if you find yourself looking at the bottom of these, or looking at the bottom down there and saying, oh, the mass number of carbon is 12.011, I'm just going to round it off. That's incorrect. All right? The mass number might be 12, and it might be very near 12.011, but it is not 12.011, because the mass number would have to be what kind of a number? A whole number, right? It's just protons plus neutrons. We'll talk about that as we do these, as we go on. So let's talk about how we're going to do these atomic notations. You ready? These are just ways to write the formula, to distinguish one atom from another, okay? And we're going to use 2 methods to do this. The nuclear symbol and a hyphen notation. Okay? The nuclear symbol looks like this. Before I get to the example. The nuclear symbol looks like this. You simply write the symbol of the atom you're talking about. Wait till I write all this down so you know how to write it. And above it is the mass number. Above and to the left as a superscript is the mass number, and then the atomic number below it and to the left as well as a subscript. Okay? So it'll be the mass number over the atomic number and then the symbol. It is not a division sign. You're not dividing. It's just mass number over atomic number and then the symbol. So, for example, I would have a guy like this. Okay? Now, if I give you that much information, you can tell me everything else I need to know, believe it or not. Probably should have told you to skip a little bit of space, because I'm actually going to fill in a little chart here. I want you to tell me everything I need to know about this guy. Okay? Let me show you what I mean. Let me have you do this. I'm going to write that same thing down, but I want to have headings over here. Number of protons, number of neutrons, number of electrons, mass number, and atomic number. Okay? So make that little chart here. We're going to fill that in for this first example, carbon 14. We'll fill that chart in there for it. I can tell everything I need to know about that atom from that notation. It tells me everything I need. I don't even need a periodic table to do this, which is nice. The next system you will, and I'm going to pass it out to you. I'm going to pass you the periodic table down in a minute. Because, number one, take a look up there. That periodic table is incomplete. I needed it to be large so I could point at it, you could see it, and 90% of the atoms we use throughout the year are on it, but it's not complete. It's only about half full. Look, even this one's not complete. I had to cut it off because it ran out of space here. Not complete. That's why I'm going to give you a periodic table. That's the one you're going to want to use most of the time, because you won't be searching for an atom that isn't there. All right, it's not up there. Barium's not up there. So if I have a question on barium, he's not there. It's too far down on the periodic table. He just got cut off of the wall. All right, so carbon 14. However, this one you can see. You can see up there, okay? And you don't need it for this guy, though, because it tells you what the mass number is, 14, and it tells you what the atomic number is, 6. So if I know the atomic number is 6 and the mass number is 14, can I fill in the rest of that stuff? Sure. I know how many protons he has, because the atomic number is the number of protons. How many electrons must he have if he's, and we're only talking about neutral atoms at this point, how many electrons must he have if he's neutral? 6. He has to have 6 negative charges and 6 positive charges. Protons are positive, electrons are negative. How many neutrons would he have to have? 8. Everybody see why it would be 8? But if you don't, let me show you. Mass number is protons plus neutrons. 14 is the mass number. 6 is the atomic number. So there's 6 protons, and there's 14 total protons and neutrons. 6 from 14 is 8. Okay? All right. What if I gave you it a little bit backwards? Can you write the symbol for this guy? I'm not going to do a lot of these. Like I said, it's only going to take me about 10 minutes to give you these notes. What if I gave you the information over here? That's what I'm going to do in the first of the worksheet you're going to get. You're going to get a chart, okay? You have to fill that chart in. And sometimes on that chart, you're told the symbol, and you're told the formula, but other times you're just given the stuff over here. So what if I told you had, let's say you had 8 neutrons and 7 electrons. Can you figure out everything else from that? Yeah. Let's take first. Who would be first? I would say the first thing I would find, knowing I have 7 electrons, I also have 7 protons because it's neutral. And if there are 7 protons, its atomic number is also 7, correct? If he has 7 protons and 8 neutrons, what must his mass number be? Everybody agree it's got to be 15? Right? And therefore, what would the symbol look like over here? Well, that's where you need a periodic table. And that's why I'm going to pass them out, like I said. But right now, I'll pass them out in a second. Right now, we can still use these. What element does that have to be? It's nitrogen. You can tell not from the mass number, but from the protons, the atomic number. The atomic number is 7, so he must be N, and 15 over what? 7. Okay? Got it? Fill all that in. That's what you should have. Okay? Everybody got that filled in? Because that's exactly what you're going to be doing. Notice there's multiple ways. Sometimes I'll give you the mass number, sometimes I'll give you the atomic number, sometimes I'll give you protons, neutrons, electrons, sometimes I'll give you the symbol. Okay, there's another way to do these, though, besides that. I'm going to keep this chart up here. We're going to keep going with that chart after I give you an example of the next one. It's called the hyphen notation, and he looks like this. I don't know the third example. He looks like this. You simply put down the symbol followed by the mass number. It's not quite as descriptive, and you need to use the periodic table a little bit more because it doesn't tell you the atomic number when you do it this way. So, for example, if I gave you O16, I would write it that way. Now, again, I kept this chart. We're going to continue that chart. Can we fill in? I don't need to rewrite it. Can we just keep going for this? Can we know everything we need to know for this? Let's look at the very first one, number of protons. I don't know it. I don't know how many protons he has from this. I have to look at the periodic table. I have to look up there. How many protons does he have? 8. Now, some of you are going to say, well, it's half. So it's always half. Is it always half, the mass number? No. In this case, it happened to be half. You know what? Turns out, in many cases, the number of protons is around half the mass number. Around, but not the same exact number. Don't just make that assumption every time. All right. If he has 8 protons, that must be his atomic number is also 8, continuing the same chart. And he must have 8 electrons, correct? These columns will always be the same, won't they? Electrons, protons, atomic number, 8, 8, 8, 7, 7, 7, 6, 6, 6. See it? Okay, if he's got 16 for the mass number, I'll write that down under mass number. How many neutrons must he have? He must also have 8. Agreed? All right. Because 16 minus 8 protons gives you 8 neutrons. 8 and 8 is 16. All right, last one. If I gave you these, can you figure it out? If I told you the atomic number is 12 and he has 10 neutrons. Can you figure the rest of that out? See if you can. I'll let you go. If you get this one right, I think most of you will, we'll just stop here and I'll give you the worksheets to try it. Again, you're going to need to use the periodic table. You don't have enough information without it, at least to get the symbol. Okay, you all agree if the atomic number is 12? He's got to have 12 protons. You all agree that if he's got 12 protons and he's neutral, he's got to have 12 electrons. The mass number is going to be protons plus neutrons, so that's going to be 22. 12 and 10 is 22, agreed? Right? And what will I write over here? Well, I kind of need to know what the element is, and I only know that from the atomic number of 12, which is magnesium, Mg. 12? Right, but that's what a lot of people write. They write. You're so used to, you look it up at Mg, you see the 12 there, and you automatically write. That will be the biggest mistake I'll see for just a dumb little mistake. It's the mass number that follows it, not the atomic number. I bet some people did that. Okay? All right, good enough. Now, I'll give you the worksheet.